You should have all got your marks for this. It was actually not bad. I was quite impressed. Okay, so you all got the 6 marks here. I think one or two you may have just made a little mistake with it. That's all. But if we have a look, standing in one place for 10 seconds. So remember, this is a position time graph. Yeah? Oh, sorry, girls. I haven't even connected them. Thanks, Oratile. And this is a very sketchy connection as well. Okay, sorry, girls. I'm just waiting for this to pop up on the screen here. Okay, is it all right? Okay. So remember, this is a position versus time graph. Your x-axis represents your frame of reference. So if something is constantly the same distance away from the frame of reference, then it is standing still. Okay, so this was 5. Standing in one place for 4 seconds, then moving away from the point of reference at a constant rate for 6 seconds. So standing still, then moving away from the frame of reference. Okay, so you can see the change in position has increased. So that would be number 3, moving away from the point of reference at a constant rate for 10 seconds. So moving away, constant rate. There it is over there. So that's number 1. Moving towards the point of reference at a constant rate. So that's that one. So 6. Moving away from the point of reference at a constant rate for 6 seconds and then towards the point. So moving away and then towards. Okay. For 4 seconds. So it wasn't as long, and that's why you can see the time wasn't, it didn't reach back to where it was. So that is 2, and then obviously the last one would be 4. So moving towards the frame of reference for 5 seconds and moving away for 4 again. If it was for 5 seconds, it would have landed up in the same spot again. Okay. All right, so let's take a look at the sketch of the graphs of the following motion. So moving away from the point of reference at a constant rate. Now, I don't know if my wording was a bit funny here, but it was supposed to be, and you can use this as your, if you want to, or you could have drawn your own axes. So, it meant that you had to move away from your frame of reference. So in other words, you were starting at your frame of reference. So you moved away from your frame of reference, and then you moved back towards your frame of reference. And sketch graph means that you can put the 5 there and the 10 there. Be careful, some of you are writing 5 seconds over there and 10 seconds over there. You can't do that. That's not a graph, okay? You're going to have, this is the time axis. So the time where it was moving away was 5 seconds. The time when it moved towards was another 5 seconds, but in total, it would have been 10 seconds. And you just have to show the 0, 5, and 10. You can't show any, wait, we can we? No, we can't say what distance they moved. I didn't give you that information. So we couldn't have put any values over here for the distance or change in position. Is that okay? Mm-hmm. All right, then this one was standing 5 meters away from the point of reference. Now this was a tricky one because you actually needed a negative side. Okay, so this is our x in meters and here is our time in seconds. So 5 meters away, so you could have put a 5 over here because it was 5 meters away from the point of reference was 4 seconds. So at 4 seconds, that's how long they just stood there. And then moved towards the point of reference at a constant rate, reaching it in 3 seconds. So that means it must reach it at 7 seconds because it's an extra 3 seconds. Okay, then continuing in the same direction for another 4 seconds. So it continues past the frame of reference. So it was on this side of the frame of reference. It's now on this side of the frame of reference. Remember, this graph doesn't really look at the negative or positive directions. It looks at, are you on this side of the frame of reference or are you on this side of the frame of reference? Your gradient can give you what it is. So it is a negative. So a negative gradient will give you, obviously, the negative direction. Okay, but it's negative the whole way. They landed up going the whole direction. It was the same direction. They didn't just stop and change direction here. They carried on in the same direction. Okay, so imagine this. So you see your friend, they stand still to decide whether it's you or not with your mask on, and then they walk towards you, and then they realize, oh, it's not my friend, and then they carry on past you. Okay, that's what the motion is. So it's a straight line motion. So you can imagine, oh, there's my friend. I'll stand here and just stare at them for 4 seconds, and then I'm going to walk towards them. Oh my gosh, abort, this isn't my friend. And then you carry on walking. Okay, that's what that motion is. All right. I'm really sorry, my heading jumped. So that should actually be there. So now I want you to have a complete shift. Throw everything you know about a graph out the window now, because it's now a different type of graph. Forget about the position time graph, okay? Position time graph uses frame of reference, it has curves, and we deal with a gradient that is the velocity, okay? Completely different graph now, all right? We don't look at that graph anymore. Now we are going to look at this graph, okay? And we are going to say, okay, now let's plot a velocity time graph. Now, be careful when you do this. Can you see that you've got negative velocities? So we need a little bit of a negative side. So let's see, it goes up to 10 and it comes down to -4. So let's see what we can do. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10, 2. Oh, it's time I'm looking at. What a dog. Yes, you're right. I wasn't even looking at it properly. Sorry, it goes up to 6 and down, so we need 10. So 1, 2, 3, 4, 5, 6, 7. Oh, that should be fine. Okay, so let's see. If this is 0, then we have 2, 4, 6. Or can we go? No, we can't go 1, 2, 3. Hey, no. We're going to have to go in twos, hey? Okay, so if we do naught here, that can be 2, 4, 6. And this is velocity in meters per second. This is -2, -4. Okay, girls at home, you okay?
Yes, ma'am.
Okay.
Yes, ma'am.
Cool. All right, so there is our axis, and this is time in seconds. Now, girls, sometimes you might be tempted to want to draw the x-axis at the bottom and keep those negatives there. You cannot do that. You have to move your x-axis to wherever the 0 is, okay? All right, let's do this plotting. Okay, so 0, 0. So we're starting at rest when we start our time, okay? Then at what? Oh, we didn't do our thing. So can we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? Yes. So that can go in ones. That's cool. Okay, so 1 second gives us 2. Okay, I'm going to let you just plot on your own. Don't forget, if you need to plot on an axis, plot on an axis. It's really okay. Okay, when you're done with that, you can do this. Now, velocity time graphs only ever have straight lines, no curves. Okay, no curves. Okay, no curves in a V versus T. Okay, I'll give you a few more minutes. Okay, you guys ready? Guys at home, are you done? Who's not done? Must I wait?
No, ma'am.
Thank you. Okay, so let's talk this through. Now, remember what I said to you. You compartmentalize these graphs. There's a set of rules for position time graph, okay? There's a set of rules for velocity time graph, and there's a set of rules for acceleration time graph, okay? This is now a velocity time graph, and you need to now go, okay, I'm ignoring the position time graph now. I'm focusing only on a velocity time graph, okay? So a velocity time graph, the x-axis is not the frame of reference, and I'm going to just show you. This indicates a positive direction. So if anything is plotted on the positive side of a velocity time graph, it is whatever direction you have chosen as positive. I just want to make it clear as well, when you are telling me a direction, please don't give me that it's going in the positive or negative direction. I want you to give me an actual direction. So left, right, up, down, or if it's a bearing, if necessary. Okay. You have to know what direction is the positive direction and what direction is the negative. And very often you can choose that. Okay, which means that anything under here is the negative direction. So anything that has changed here, can you see how this is a little different to our position versus time graph? Position versus time was, are you on this side of the frame of reference or you're on that side of the frame of reference? Now we're going, if you're on this side, you're going in the positive direction, whether you have chosen it as left or right, it doesn't matter. And if you're plotting something on the negative side, it is now going in the negative direction, which would be opposite to the positive direction. Okay. So what does the x-axis represent? The x-axis does two things. Okay. Firstly, the x-axis is the point where the direction changes. Okay, so direction changes. Okay, direction changes. on the x-axis. Okay. What else can you tell me about the x-axis? What is the velocity on the x-axis? 0. It is also a 0 velocity. Okay, so if you have something, a line that is approaching the 0 line, what do you think it's doing? It's decelerating, it's going towards 0, and so it's slowing down. If you have a line that's moving away from the 0 line, you are getting faster and faster, and you are accelerating. Okay, so let's take a look at what is happening here. What color can I use? Let's go with pink, because it's in the positive direction. Okay, so here we have a positive velocity. It's going in the positive direction. Should we say it's to the right? Okay, so for example, we have chosen our positive direction as to the right, okay? And so we see, oh, this object's going right, okay? Doesn't matter where they are relative to their frame of reference, okay? It doesn't matter. They're going to the right, okay? They also have a positive gradient, okay? So positive gradient, right? And you can literally see how the value of the velocity increases over time. There it was 2, there it was 4, there it was 6. So you can literally read off the graph that it's increasing, okay? The velocity is increasing, therefore there is acceleration. Is it a positive or negative acceleration? How do you know? It is a positive acceleration. We know it's getting faster and faster and faster, yes. But what else tells us that it's a positive? The gradient. The gradient is positive. Therefore, positive acceleration. So if you plot this on a acceleration time graph, it's on the positive side. Okay, the gradient is positive. Okay, why do I say it's an acceleration? Well, how can we say that the gradient is acceleration? Remember, it's a change in y over the change. How do you get gradient? Change in y over change in x. You know that from maths. Our y value is velocity, and that is in meters per second. Our x value is in seconds, and look at that. It's meters per second per second. That is the unit for acceleration. So the gradient of a velocity time graph is acceleration. Now remember I said to you, start with the position time graph at the top. Go down to velocity time graph. Go down to acceleration time graph. Can you picture them? You can picture this order. When I'm moving down this order, the next one down is the gradient of the previous one. Okay, you should see this progression. The position versus time graph is simple, just meters per meters and seconds. The gradient becomes the velocity. This is a velocity time graph. This gradient becomes the acceleration. It builds up. Okay. Tell me about this situation here. What is the gradient?
0.
0. Okay. 0 gradient. Okay. Gradient equals 0. Tell me, what does that mean? What is your gradient? Acceleration. What is acceleration here? 0. Remember, the gradient is your acceleration. Your gradient is 0, 0 acceleration. Can you see it though? Have a look at the velocity here. At 3 seconds, it's 6. At 4 seconds, it's 6. At 5 seconds, it's 6. There is no getting faster or no getting slower. We haven't changed direction. We're still on the positive side. We're still pink. Are you happy with that? Girls at home, you understand?
Yes, ma'am. Yes, ma'am.
Yeah. Now let's take a look at what's happening. What is this now? Let's just talk about what you see from the graph. We can see that the graph is going down in velocity. Can you see? It's approaching 0. So what is it doing? It's decelerating. Okay. And we often say it's a negative acceleration. But based on this, we can see that it is decelerating. Yeah, we can see it's a deceleration. How can you see it's a deceleration and not an acceleration in the opposite direction? It is getting slower, but can you see that it's still on the positive side? It's still on the pink side. Okay, so, and we have a negative gradient. A negative gradient, therefore a negative acceleration. And we can see that it's still in the positive direction. Remember, all the pink is positive direction. Okay, all positive direction. We're still going to the right. But how can we still be going right? Just because we're slowing down doesn't mean that we change direction. So imagine you're going faster, 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 faster to the right. You reach a point where you don't increase or decrease anymore. You then put your foot on the brake and you decelerate, 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 but still going in the same direction. Imagine this is a forward and reverse. Imagine you are going forward, there's a robot, and you stopped at the robot, and now you're going to pull off. You get faster, 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 faster. You reach the speed limit you want to reach, and you go constant velocity. Oh, there's another robot going to catch you. So you decelerate and you stop. Oh, no, sorry. Yes, yeah, that's right. Okay, you decelerate, you stop. Okay. Now something happens. So we know what happens here. What is that? Is it changing direction, and what else? It stopped. In this case, it stopped for like hardly any time. Okay, no time at all. So this is a stop and a change in direction. Sorry, that was really badly written. It's a triangle for changing and then direction. That is a stop and a change in direction. So imagine now you stopped at the robot for a split second, and then there was a broken down car in front of you. And so there was nobody else on the road, so you reversed a little bit. Okay, so let's talk about this now. Now we need our green. Now we have negative direction. Okay, this whole time we were going forward, 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 forward. I stopped for a split second, and now I'm going back, 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 back. Imagine we were just walking. Imagine we were running. I said to you, oh, quickly, go to my classroom. And and I said, go, sprint. And you started running faster, faster, faster. You then started just, not walking, but started going at the constant velocity. You then slow down, stopped, you pick something up for me, and now you came back a little bit. Okay, and that's where our motion stopped. If I asked you to come all the way back, then that would be a whole different more of that. Okay, so tell me this motion. Is it going towards or away from the zero? Away. So what do you think it's doing? Oh, Tilly, you have a headache again. You have a headache again. I can see it in your eyes. Sorry, my girl. Okay, sorry. Say that again. What are we saying here? It's increasing. It's getting faster, faster, faster. Girls, please, this -2, -4, in science, the negatives are just a direction. Okay, but your magnitude is getting bigger. You're going from 2 to 4. So you are getting faster over here. Okay, so our velocity is increasing here. Whereas here it was decreasing. Okay, do we still have a negative gradient though? Why is my acceleration still negative? What is going on here? I had a negative acceleration here, and I've got a negative acceleration here. My gradients are both negative. How do I get a negative acceleration here when I'm increasing my velocity? Anybody? Remember, we don't look at point of reference here.
Changing direction.
Changing direction. We are now in the negative direction. So we have a positive acceleration because it's getting faster and faster and faster, but it is in the negative direction, and that is why the acceleration is negative. So a negative acceleration, what does that mean here? It means that we have a positive acceleration because it's going faster, but it's negative direction. Okay, therefore, a positive and a negative will give us a negative acceleration.
But I thought acceleration was negative.
Acceleration is negative. Oh, what I mean by that is it's a positive. We normally talk about a positive acceleration of getting faster and faster and faster. And a negative acceleration is getting slower, slower, slower. But when you add direction into the factor, that's when it becomes a negative acceleration. Okay, so overall, it becomes negative once you've taken the direction into account. If I'm just looking at the magnitude, it would be positive because I'm getting faster, faster, faster. But when I'm looking at in terms of direction, because it's a vector, it's negative because it's getting faster, but in the negative direction. Okay. Girls, any questions on this? I'm really going to need you to watch this a few times to get it. Because I know you guys think you get it now, and then when I ask you a question, you're going to be totally, I have no idea what's going on. I know this word. I know it. Okay, so I need you to keep going through it. I need you, every time I give you a graphs thing to do, I want you to keep going back to these notes and going, what does this mean? Is it velocity? Remember, compartmentalize these graphs. There's rules for position time graph. There's rules for velocity time graph. The more you work with them, the better this is going to get, the easier this is going to be. And girls, we are starting them now. So by the time you get to matric, you'll be so good with graphs. And nearly every question in your physics paper has graphs. Okay, so you please, 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 I need you to actually explain this to somebody. I almost want to do that as your assessment, that you have to put together a presentation for me. Honestly, that's how much I need you to get to know this and to understand this. Okay, so let's describe the motion. Who would like to try? Anybody? Should I just do it? Okay. So there is velocity increasing. Let's just go ink. In brackets, you can put accelerating, velocity increasing in positive. Now, normally you wouldn't write a positive direction. You would actually give me what that positive direction was. Was it left, right, forward, back? Okay. And then that would come from the question. You will know from the question. Velocity increases in positive direction. Okay. After 3 seconds, velocity is constant, 0 acceleration. After 5 seconds, decrease velocity, negative acceleration. Sorry, we're going to have to take some time and some more space here. After 5 seconds, decrease velocity. Oh, what did I do? Sorry, it's not after 5 seconds, it's after 2 seconds. Can you see why? Because it was after 3 seconds and then another 2 seconds to make it overall 5 seconds. So that was, sorry, that was my fault there. Decrease velocity. Okay. Then after another 1, 2, 3 seconds, we stop. After 3 seconds, stop. And then we'll increase velocity. Increase velocity in negative, let me write the word negative direction. That gives you a negative acceleration. So velocity increases, and girls, you can really break graphs up. If there's a change in something, so only go up to 3, because then something changed about our graph. Then talk about that line, then it changed. Then talk about that line because something happened there. Then talk about that line. You can break this up really nicely. If you want, you can even label these and say, that I'm going to label A, that I'm going to label B. From A to B, it did this. B to C, it did this. Okay, so you can actually do that as well. So what could we use the x-axis as? This is going to be our 0 velocity or changing direction. Remember, the triangle or the delta sign means changing direction. At which time was the car decelerating? Between which times? 5 and 8, yeah. You're right, it's also 6 and 7 in there, but we know it's going from 5 to 8 seconds. Which time was the car stationary? It still had a velocity. Okay, it can't be 3, even though we know the gradient was 0. All it means is that the acceleration was 0, but it was still moving. You can see it still had 6 meters per second. It was still going. It would be at 0 and 8. Remember, this is our 0 line. 0 and 8 seconds. At which time was the car going in the opposite direction? From 8 to 10 seconds. Okay. Luckily, girls, there's only these 3 graphs to learn. And then these are your rules forever. There's nothing more I can tell you about these graphs. Well, there is one little bit more, but after this, there will be nothing more. You're going to have everything in this pile of notes that you can then answer graphs to matric. Okay. Nothing can change. It's just how you understand it. All right, let's take a look now. Let's match these together. Okay, A says a constant velocity for 10 seconds. Now remember, this is not position time graph. Okay? You are considering a constant velocity, which means that it just has a velocity that is not changing. For 10 seconds, there's a zero acceleration. Which graph? Number 5, absolutely. Oh. Number 5 is it, because look, it has a velocity, but it's a constant velocity. It hasn't increased its velocity or it hasn't decreased its velocity. It has just maintained that velocity for a constant time. Okay. Decelerating, not for constant time, but anyway, decelerating for 5 seconds. Now, what does decelerating mean in a graph? How would you identify a deceleration? A negative gradient, yes. But be careful about a negative gradient because we know what else it could be. It has to approach the zero line. Okay, so yes, a negative gradient. So we have a negative gradient here, and we have a negative gradient here. So let's take a look. Decelerating for 5 seconds to the right, then stopping, then accelerating for 5 seconds to the left. Which one do you think it is? 4 or 6? Is it? It's 6. Okay, let's have a look at why. Look here. It's decelerating, it's approaching the zero. Remember, that means it's stopping at 0. So it's slowing down. Okay? Then it changed direction. Okay? We called it right. So it's actually going right up here, and now it's going left. So our positive direction is right, according to this. And now it's speeding up. Can you see how it's speeding up? The magnitude of the velocity is increasing. It's just in the negative side. It's moving away from your zero. That means that it's going to get faster. Okay. Decelerating for 5 seconds to the left. Okay. Stopping, then accelerating 5 seconds to the right. What does deceleration mean? You're approaching the zero line. Left is negative. So you're on the negative side and you're approaching the zero line. You're then stopping, so you have to reach the zero line. And then you're accelerating, which means you're moving away from the zero line. Anyone?
1.
1, absolutely. Look at it. We started at a velocity. We approached the zero line. It means that we were decelerating. We stopped. We went faster, faster, faster in the other direction. But we started in the negative side. So we started left. Remember, this whole thing is left at the bottom, right at the top. It can change. You don't have to have right at the, as positive. Okay. Decelerating for 2 seconds to the right. So we know it must be above the line. It's approaching the zero line. Stopping, then accelerating for 4 seconds, then decelerating for 4 seconds to the left, and then stopping. So we're stopping twice. Must be 4. Must be 4. Okay, let's just take a look. We are decelerating for, what did I say? 2 seconds? Is it 2 seconds? Yes. Okay, remember, above the line was right, below the line was left. Okay, so we're going right, 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 right. We stopped because we slowed down. We changed direction. We speed up. Go faster, faster, faster. Oh, I forgot something. No, we didn't forget something. We just started slowing down. We're still going left. We just slowed down. Please get, even I had a little bit of a wobble there now, because you must get it in your head. This is not position time graph. We didn't change direction here. We were going, we went left, 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 but going faster, faster, faster. I'm still going left, 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 but I'm going slower, slower, slower. And then I stopped. Okay, so be careful. This is still left. Different graph. Stationary for 4 seconds, then accelerating for 6 seconds. Stationary means what? Zero velocity. Where's our zero velocity? 3. Okay, then from rest, accelerating slowly for 3 seconds. Okay, there's only one left now, but no acceleration for 5 seconds. Is it a quick deceleration? Now, have a look how I said this. So I said from rest means we start at 0. Okay? We are accelerating slowly, so we're getting faster over a longer period of time. We then don't get faster. We are going at a constant velocity. Then we quickly decelerate to a stop. We're still going to the right, remember? We're still going right. Okay, so it's like you're running away from somebody and you increase this velocity, you then go at a constant velocity, you then slow down and stop, all in the same direction. You still just keep on going. Okay, how did I know that this was slow and this was fast? Okay, yes, so what does that mean? What is different between them? What is the term here? We've got different slopes, different gradients. Okay, so you can see, and we know that our gradients mean acceleration in this type of graph. So we have a lower acceleration over here because our gradient is lower. Here, our gradient is faster or steeper, sorry. Our gradient is steeper. We have a higher gradient here. Therefore, we have a higher deceleration. Okay, so it decelerated a lot quicker. Okay, so that's number 2. How are you guys feeling? Is your brain fried? Okay, what I want you to do then is, before we move on, I'm going to let you try these 2. Okay, so I'm going to let you think about these 2, sketch them, and what's the time? You know what, I'll let you sketch them and then we'll mark them tomorrow. Okay, so we'll finish there for today. I just want you to do these 2 and then we'll stop. Unfortunately, the exercises I want you to do, you need to know everything about graphs before I can give you exercises. So I'm planning on finishing this up, and then we're going to do some of the exercises, and then next term we'll finish with the exercises. Okay. And you'll only really get it once you're practicing. Okay, I'm going to stop the recording. Any questions, girls?
No, ma'am.
Okay.